Welcome to a new episode of my Home Automation OpenHub and Node-RED series. Today I want to talk about chat integration with Node-RED, and in this specific case I want to talk about Telegram, which is a messaging application. I don't know about you, but I grew up with MS-DOS back in the, what was it, 90s probably. So I'm quite used to type commands and remember different commands, and that was the way how I used to interact with a computer. And even today we are using many chat applications like WhatsApp, Facebook Messenger, and I wanted to have some sort of messenger integration with my Node-RED, because in many cases it's easier for me to type in commands and then wait for the response, or just to get notifications via like a chat service that I can reply to. Naturally, I wanted to do the integration with WhatsApp because that was the messaging app that I knew, but it wasn't really straightforward, and I've actually given up after a couple of tries. And then later on I stumbled upon Telegram based on another example, and that's just yet another messaging application like WhatsApp or Messenger or Viber. It uses the same concept where you have a mobile application that you download to your phone, you register it with your phone number, and then you can start messaging. But then it has one crucial feature which is absolutely useful for Node-RED or the integration itself, is that within Telegram you have the general users, but you can also create bots, and bots act like chat rooms in like an IRC chat service, where user can connect to that bot and can send messages to that bot. An external application, for example Node-RED, can connect to this bot, so all the messages that are going to this bot from users are captured by Node-RED, and then Node-RED can decide how it's going to respond to those messages and then can send the messages back. So that's how the whole integration works in a nutshell. So what I could do is create a bot for my Node-RED system and then have a flow in Node-RED which is linked to this specific bot. So whenever I send messages from my Telegram user to this bot, Node-RED is able to pick this up and able to respond. And the response could be quite different. As you can see, I have some of the responses are text, some of the responses are voice responses, some of them are images. So I can have my IP camera to send an image when somebody rings the door, and I can have just static messages that, for example, one of my ESP is not working, not transmitting data. And in other cases I can have commands like turn on the Christmas light, and then Node-RED will say that yes, turning on the Christmas light. So these are the sorts of applications I was able to do. So in this video I'm going to go through my examples that you can use to create your own Telegram integration. In order to keep this video short, most probably it's going to be quite long anyway, I'm not going to go into the the every single detail of the code. So if you want to implement this for yourself, then most probably you have to do a lot of digging in order to understand how this actually works, and look at the messages going in and out to really understand the details and how to adapt it for your own scenario. So it's not going to be a very easy plug and play code. You definitely would need to spend some time and probably modify some of the JavaScript code, but it's not that difficult. But and that's only just one concept. You can implement this in probably many different ways as well. As you can see, the code is, or the flow is fairly extensive, but it has quite a few integrations with some of the other Node-RED code that I have written. So for example, the IP camera integration, or my integration with my system diagnostic framework. So I can have my Node-RED to send me information. For example, if one of my ESP is not working, and have it sent to my Telegram account. And with this one, I also have a small UI front end, which is just mainly about the user management. I'm going to talk about that a little bit later. To start with, I want to show a blog post that I found. I mean, probably there are quite a few blog posts how to create a Telegram bot, but this is one that I used, and it explains how you can create your own bot. And it's a fairly easy process. Basically, you install your Telegram on your phone, you create your account, you link it to your phone number, so it's pretty much the same process as you would have seen for WhatsApp and Viber. And you find this bot, which is called the bot fodder. And then here, the bot fodder has a couple of new commands. So you can get these by typing /help, and then one of them is a new bot. So you type /new bot, and then you go through the process. So the bot is going to ask you, or the bot fodder is going to ask you a couple of questions. For example, what should be the name of your bot? What should be the ID? Which is probably something similar without spaces and uppercases. And then finally, once you are done, you will get an API key, which then you will use later on to link it with in Node-RED. And once you have done, the bot is created. You can find your bot just like as you would find a new contact, and you can add it to your, well, let's say to your account, or you can start a new chat with this bot. And then once you start chatting with the bot, obviously nothing is going to happen, because by standard this bot doesn't really do anything. So it's basically just accepts your messages. But now you can have Node-RED to process these messages and then respond something to it. And as you can already see from here in Telegram, you can send messages like just simple text, but you also have some commands which start with /. And this is how you handle the different kind of inputs that you can receive from Telegram. But let's go over to the code first. And first of all, I just want to show that there is the Node-RED contrib Telegram bot. So that's the component that you want to install. Ooh, and I'm fairly out of date, so probably I should update this component or this node. And then once you install it, then you will receive a few different nodes. So first of all, they are going to be in the Telegram group, and you have a receiver, a command, a callback, a sender, and a reply. And to be honest, I have only used the command and the sender in this code. And basically what the command does, it listens to a specific command. So you can have one of these nodes to listen for example, /start, and the other one to listen to /register. And you would only get the output once that message is, once that specific message is sent, sent to the bot. And the other one is a sender, is whenever you are sending something to the sender. When you place any of these nodes and then you go into configuration, so if it's a command one, you have to specify the command that it should listen to. And in the bot, you configure which bot to link to. So I'm going to go into the details, but basically you have to give the name of the bot, what you have defined in the bot fodder, and also the API key, what the bot fodder has given to you. And that's all. So that's all you need to do. You can have as many commands as you want. And in the sender side or the reply node, the only configuration you do is link it to the bot. And that's pretty much it. And of course, there is a certain documentation what sort of message you need to send in. The other thing you have to keep in mind is you create these bots, and these bots are not restricted to any users. So anyone who basically stumbles upon your bot can add it to his chat and can start send messages. So that's why I implemented a whole user management concept in my flow. So when you send a /start, then this node will fire because that is listening to /start. And as you can see here, I've connected this start to debug one, so we can see what is coming through. And every time you receive a message, it will have a certain structure. So that structure would have a payload in which you have a chat ID, and that's going to be a unique ID for your user. So every time you are sending a message from your user ID, it will have this same chat ID. There is also a message ID, and there is a type, which is a message, and then a content, which is empty now because we have sent a comment. But if you're sending a free text, that text is going to be in the content. And also there is going to be an original message which contains pretty much the same content. So for example, in the original message from ID, we can see the same chat ID. And also, well, you also have a chat ID here, and then the username, and then the date, and then the text, which in this case was /start. So this is how you would receive any text from the Telegram Messenger. And the way you respond to it is you can create your own text that you want to send out, and basically you also put it into the message.content, and that's just a free text, anything, and that goes into a response node. So the response node would also have this kind of structure. So for example, the mandatory field is that you also send a chat ID. So that's how the Telegram bot knows that this message from the bot, it goes to your ID and not to somebody else. The message type has to be a message, so it's like a text message, and then the content is the content that you receive. So here I have said that if somebody types /start, then he will receive some information message that, well, this is the bot for my home automation system, and first you need to register, and that's your chat ID. And then what's your username and that sort of stuff. And if I go into the application itself, you can see that that's the message that we have received. Just ignore this unknown function. So the next step that I've implemented is I've implemented register, where basically you send in the /register. You don't have to send any more information because Telegram already knows your user ID and chat ID and username. And basically what is happening in that case is a new user would like to register. So internally, I create an object where I store all the user IDs that has been registered. That is being saved in a file. So I'm using file instead of the database. So if anyone wishes to use this functionality, then probably it's easier to use files than a database. And well, this is not something that will get changed very often because after user registers, then well, they don't really change so much. So this function handles all the registration, which is basically, saving the user information in the user list and saving the user list in a global, and also, well, then outputting it into a file. And then once that user registers, then it also appears on the UI in the user list. So you can see that at the moment it's me, and I also have my missus, who is has the Telegram client installed, so she also registered, so she can also send some messages or receive messages from the system. And here you have a user management where you can select any of these users, change the log level, the mute, the block, and then update this user or delete this user. And just for reporting purposes, I also keep track how many messages I have received from Telegram users, and how many of these were unauthorized requests. So these would be requests that are coming from users that haven't registered. And so it seems that, well, there are no users in Telegram who just, randomly find bots and send messages. But I guess it's better to be safe than sorry. And for every single user, I have a couple of attributes. So obviously the chat ID and the name that comes from Messenger, Telegram, so that doesn't need to be changed or updated. And I've implemented an access level control where every function that you execute requires a certain access, which, for example, you can change the lights with, access level 1, but if you want to arm the alarm system, maybe you need access level 2, or, well, you can decide how you want to split this. The log level and the mute log is something which is again specific in my installation. I have done this system diagnostics framework, which I have a separate video on. So there is a piece of flow in my Telegram, in my Node-RED, which monitors various devices, my ESP devices, and whenever something happens with them, so for example they stop transmitting or they're rebooting, then each of them generates a log, And this log is also directed to Telegram. So I can define if I want to see all messages or just the critical messages. And the log mute is a functionality where I can just say that I want to stop receiving messages for, let's say, for the next 8 hours or something like that. And also users can be blocked, so they remain in the user list, but they can't access any of the functions within Telegram. So I thought these are necessary to, just keep control who is using the Telegram bot and who has access to some of the functions in the Node-RED. And the user management is basically done here. So that's the piece of the code which generates all the UI element that you have seen here, and also it does all the updates. So that's where you can store the access level or the log level or the block status, and all of them would update the global variables and update the file itself. And whenever Node-RED restarts, then it reads the file, the same user file or telegram.json, and then restores the user information. So it automatically updates itself whenever Node-RED reboots. The rest of the code, which is further down here, is really about handling all these Telegram messages. Well, I wanted to keep it simple. So for example, I want to have specific commands that I type into my Telegram, very simple ones, that would execute a particular function. So they don't have to be like, a complete English sentence, just something like if I type me, it will give information about, my specific user. What is my chat ID, what is my access level, my log level, and that sort of stuff. If I type camera, then it goes to my IP camera, and then it will send a message, it will take a picture and then send that picture back into my Telegram. And that takes a couple of seconds because capturing from the RTSP stream takes a little bit of a time. So if I want to, I can look at what is happening in front of my house, and actually I'm getting the same kind of image whenever somebody rings the doorbell. So the doorbell is again connected to my Node-RED via an RF bridge. I have talked about this before in a separate video, and that also triggers the same image to be taken from the IP camera. So these are the simple stuff, like you send a command and then you receive like a text or an image information. And by the way, when I talk about commands, what I've implemented is, instead of typing like a slash command, for which you have to change the keyboard, so it's a little bit complicated in the phone, I decided that I just want to send simple text. And that's why here in the code I'm using the Telegram sender node, sorry, the receiver node instead of the command node. So because that's the one which listens to all the texts which are coming in. So that is one. The other nice feature in Telegram is that in some cases, for example, if I do log level, so I want to change my log level. So I can do this log level and I can send in like, log level 2, but if I'm not sending any parameters for this command, then what I can do is I can give options to Telegram, which are displayed something like this. So my current log level is 2, and then now it shows me all the other options that I have, and these are shown in buttons, as buttons here. So I can just quickly select the ones that I need, and then that goes back as a second message. And it's just a really nice and convenient way to to interact with Telegram, because I don't have to type a long sentence. I can just type a keyword and then you will get options. And I have implemented the same for one specific command, which is like turn or switch, so switch on lights. So I can say turn on the Christmas light, and I will get a message back saying that turning the Christmas light, well, it says on, it should say on. But what I can also do is, if I just only type turn, then the system knows that I want to switch on some lights. So then it gives me an options like, okay, I want to turn the garden lights, and I want to turn it on and off. So I want to turn it on. So now it says turning the light on. So I've also managed to do this conversation, whereas you start the conversation and then Node-RED would respond to you with a couple of options. You select one and then it takes on, and then you go into the next let's say parameter, which again a set of options. So you can go through quickly by just clicking on these buttons. And if you know how this works, then you can implement a really nice solution where you only have to type a little and then you get like options, and then just quickly select the buttons, and then that's it. The whole thing is done. So these are the different things that I've implemented here. So now I can go through the code and quickly go through how it works. Oh, and actually one more thing. What I have also done is I have one special command, which is help. So if I do this, I get a long list of long message where I have all the different commands. So for example, you can see the camera and the me and the log level that I have just used, and the turn or the switch, but I have a few more others. So you can always do help, and then every function will just send a piece of text like a help text. Similar kind of concept where you have in MS-DOS, or well, in Linux, whenever you have a command, then you can type like /h or /?, and then you have this help screen. So it's the same concept here. I wanted to implement this because I do so many different stuff, and I don't often use most of them, but sometimes I remember, oh, I have done something like this, so let me just type help and I can see the list of entries. So as I said, all of the text inputs are coming through this receiver node, which is again linked to the same bot as all the other Telegram nodes on this flow. And first it does an authorization check. So in here, simply what I do is I look at the chat ID and I check whether that chat ID exists as a user in my Telegram database or in my Telegram user list, and also checks if this user is not logged or anything else. And depending on whether this user is authorized or not, so if the first port says or the message comes through the first port if the user has access, so then it follows on to the next node, and if it doesn't have access, then it goes to this response text. And then here you can see that I'm setting the payload content to "you are not authorized." So whenever this happens, you will get a message back saying that you are not authorized. And I've also updating the stats which are being displayed on the UI. Depending on whether the message comes out here, then it updates the authorized request. And if it comes out on the second, then it updates the not authorized request. So that's the authorization check. And the next, it goes to the language processing. And this does a few things. And one of the things it does, the basic thing, is that it looks for these specific commands that are indicating, a specific function. So no matter what if I type a full sentence which has the word help, camera, me, user list, log level, then it just ignores the rest of the sentence or the rest of the, the text, and then it would execute that particular function. So you have to select this keyword carefully, so it doesn't get used in, let's say, in any other sentences. So probably me is not a good one, but specific ones like YouTube or system info are probably fine. Yeah, probably not weather either, but well. So you can just type weather, or you can type what is the weather or what's the weather like, and then it will all execute the same function because it finds the word weather. So these are the sort of the reserved words. So first it checks that. If it finds any of these words, then okay, that's the command that I need to execute, so it carries on. And by the way, if oh, maybe I will talk about that later. And next, so if it's none of these reserved words, then it tries to treat this the text that we are receiving as like a proper English command. So first of all, it tries to remove any of the, like the A's, the D, like A, the what is to lights and that sort of stuff. So any of the I don't know, like the rubbish words, which is well, you do say in a proper English sentence. So, and then finally it assumes that you are giving a command which is like turn on the Christmas light. So it always starts with turn or switch. So that's what it checks, that in the remaining sentence the first word is turn or switch, and then it assumes that the next word is going to be the state, so turn on or turn off, and then it will be followed by a D, like a D, which, well, by this time is already removed. So the next word, or the rest of the words, is going to be the device that you want to turn. So it's a really simple way of parsing this text and understanding what is going on. And again, now here I'm evaluating the different states. So at the moment I'm only listening to or understanding on and off, which becomes 1 and 0s. And then the thing which I want to update is going to be, well, the rest of the sentence after on or off. So that's it. And we can see, oh, well, we will see this later, but and as you can see here in the code, I'm going to put all this information into the original message. So I'm expanding this message.original message with some other attributes. So for example, what is a state, what is a thing or the object, or what is the command, so whether the command is switch or any of these fixed commands. So this language processing node is my way of Node-RED understanding what you are trying to say in Telegram. The next bit is the help request, and that's fairly easy, because again, if you have the help in the text, then it's going to say that, okay, well, actually I don't need to execute any commands, but everyone needs to provide its help text. And the way I do it is I set this original message.help, saying that, okay, now we are displaying a help text, and now everyone here, because as you can see, the message comes from here to there, and then it basically loops through all the different function nodes. So whenever this function node find that, okay, now we have the message.original message.help, so it's basically a flag that we need to provide a help message, then they add their own help message to the content. And this is how I get to the end, where I have a long text with all the different help commands, because as you can see now, it's adding the message payload content with its own help message with a /r/n, so it breaks into a new line, and that information goes out on the third port, which is then being looped through all the different function nodes. So this camera will add the help text for the camera function, then the next one adds its own help function, so it loops through all of them, and then finally it comes through at the last one, and then if it was a help request, then it sends out that help request, all the way to this response. So by the time we have all the help lines here, and if it wasn't a help request but it has come out on the first node, then we just send the response text that it was an unknown function. So no one really picked it up from here, so that's an unknown function. And if it's not a help request, then the help is going to be false, which means that this function node needs to execute its function. And what I usually do here is I again check access. So for every of these function node, you can set what is the level which is required. Obviously, the higher the level, the more complex or the more severe the function is. And if the user has access, then I am sending the message out on the first port. If the user doesn't have access, then I'm sending the message out on the second port, which goes into this common one, which sends out the text "you are not authorized." And if I send out the message on the third node, then it means that this wasn't a camera request, so I need to pass the message through to the next node, so the next one can process it. So I mentioned before that whenever you have a help request, everyone just adds a piece of text to the content and passes it along. And when it's not a help request, then everyone checks if if this is a message for me, and if it's a message for me, then I'm going to execute it, and based on the authorization, I send the message, I pass the message through via either the first port or the second port, and if this is not something for me, then I just pass it along in the third port. So it basically gets cascaded through all the function nodes all the way to the end, and then if it leaves on the third port of the last one, which in my case is the system info, then it goes here. Well, it wasn't a help request, then it must be an unknown function because nobody picked it up. So because the message has fallen out at the end. And it is really easy to expand, because if I just want a new function, I can just copy this one, loop this through here, delete this one, and then, oops, and then redirect the third port to this node. So it is really too easy to expand this whole logic. And as you can see that each of these boxes are a separate piece of functions which only listen to their own command. And most of them are really, really simple. So for example, this me one, you will always find this section in the function node, which is responsible for generating the help request, and the only thing which changes between them is the actual text which gets added. Other than that, you have another set of code which checks the access level, and based on whether you have the access level or not, the message is redirected either through the third port or to the second port. So it doesn't actually do the execution, it just does the handling of the message. And if it comes through the first port, then I usually direct it to either a simple change node which sends a response, or I usually do a function node which does a more elaborate piece of code. So for example, in the me, I have to get a couple of data from either from the message object itself, or maybe from the global variable, or something else within the Node-RED system. And by the way, as you can see here, I have somewhere here, I'm not sure whether it's here in the authorization check or somewhere else, but I've also putting the access level, the lock level, and the block state of the current user into the original message.from. So I just have all this information for the following nodes to use it to whatever they want. So I would say that most of the functions that you can implement would be something really simple, like this me function, where you just handle the access level here, and then in a separate function node, you somehow generate the output, the message that you want to send back. And of course, all of these goes to this respond node or this reply node. And then you have some more complicated ones. If I take low level as an example, that would be a more complicated piece of logic here in this function node, because not only that we need to handle what's coming in, but we also have to send the response out, which is going to be in forms of these buttons that you can select. So if I go back to my Telegram, if I do log level again, and now it's connecting. And the way I do it is that, as you can see, I have so I'm setting a context. So whenever I'm sending these buttons out, I'm setting the context to a keyboard. So next time when the execution comes back here, I know that now I'm not just receiving the log level command, but now I have receiving a keyboard. I'm receiving the response for the keyboard. And if we look at what is being sent out, now you can see that we have sent out a message. So we have sent out a message here which says your current log level is 2, select the new log level. So that's the message which goes out. And that's how normally a message looks like. So you have a message type, you have a type message, and you have a content which is the actual text. But now I can send out some options as well. as you can see that I have these options which have to be in a separate JSON format, and these are the ones which are being rendered on the Telegram screen as these different buttons. So you can see that, you know, that's a keyboard type message, and then you have 0 all logs, 1 critical, blah 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 blah, and then, you know, resize keyboard true. Well, I don't know the rest of the details. I found a blog post on how to format these keyboard ones. And now if I receive one, then we can see here that we have a payload. Oops. Sorry, I just have way too many of these nodes. So I just need to find the one. Okay, so that's the one. So that's the message that we are receiving when we are doing to. So basically I've selected the, I clicked on the button to, which has this text that to : error plus system plus critical messages, and basically that button caption is coming back as a text. And what happens here is now the system remembers that I sent out a keyboard, so I'm definitely waiting a response from the user, which is not going to be a new command, but that's going to be something which is related to the previous one. So that's how I'm keeping this, you know, context in the system. So even though this command doesn't contain the word log level, now the system knows that, well, that's the response for the log level. So whenever the message comes through here and it says, oh, okay, my context is keyboard, so I was sending out the keyboard, then it starts processing that message, which is basically this one, to : and then the rest of it. And the reason I send out the options like this, so I always know that, you know, it was like 0 something, 1 2 3 4, so those are the actual log levels. So here I can just double check that my second character is a colon, so that means that, yeah, that the user has actually selected a button instead of, you know, typing something in manually, which then I can reject. And then basically, depending on this number which is coming in front, I can set the user details, or sorry, the user log level to that specific value, and then send the response back saying that your log level is this one, which we can see here on the screen. So that's how it is all working. And of course, for the turn function, when we are turning our lights, it gets a little bit more complicated because we are sending two keyboards out. So first of all, we are asking whether you want, you know, what is the device that you want to, you know, change the state of, and then after that you also provide the actual state, whether it's on and off. So here it gets a little bit more complicated because that context gets used twice. And once you have received all the commands, for example in the turn here, then, well, you know, it just goes out on the first node, and then here you can decide whether your thing or your device was Christmas, the planter, or the garden in my specific case. And you can put the state into the payload and just send that out into, well, in my case it's going to be MQTT, because all these devices are being controlled by MQTT. And as you can see, most of my other examples are very, very simple. So if I type weather, let me actually show that. So if I type weather, then as you can see, it triggers this forecast IO, and then it converts the response JSON into a JavaScript object, and then basically in the function node, I'm just putting a long text together and parsing in various you know, data, or adding in various data from this response object. And then finally you have a text. So yeah, nothing really special about that. And the same for the YouTube. So I can ask, you know, how many subscribers I have, how many views I had. So, and that's the same thing. It calls an API, and then from the response, it basically just creates a text. And I have a few other examples. So for example, this solar thing where I can ask what is the what is the stats from my solar data, and that's fairly simple. And here the response is again fairly simple, because in this particular case I have most of these data already stored in the global by another part of the flow. So I just need to retrieve them and put it into the text, and then, you know, return it. You don't really have to do anything. As I said, for every type of message, you have to provide at least the content, the chat ID, and the type. But the chat ID and the type is already coming from the incoming message. So the only thing you need to change in most cases is the content. And that's pretty much the entire flow, which handles all the incoming messages and then sends the response back. And as you can see, most of them are simple text responses. The only difference is this one, where I am putting the image from the IP camera. And that is also fairly simple. And here, the payload, just like before, it has to be an object, and it has to have a few mandatory attributes. For example, the chat ID, which you can get as the chat ID from the incoming message. In this one, up until now, we use the type message. Now, in this case, the type is photo. The content is going to be the file name. So that's the path and the file name for the image that you want to send. So from the IP camera, I save the image into basically just a JPEG, which is sitting on my Pi. And then here I'm providing the full path to that JPEG image. And then I can also put a caption. So you have a caption for the image. And that's how you send an image object. So fairly simple. The other thing you can also do is you can also send a text message. Oh, by the way, you can find all the examples. So a text message looks like this. You have a chat ID, you have a fixed ID, message type is message, and the content is a text. So if you execute this, if you send out, I will get this text message in my Telegram, and it will be coming obviously from the bot, because we are sending this via the bot. And if you want to send an image, then again, chat ID, type photo, the content is, let's say, /home/pi/grab.jpg, and that's the caption. And if you want to find a message, then fairly similarly, you have the chat ID, you have the type, which is voice, and the content is the path for the MP3 file. And that's how I'm getting these type of messages here.
The weather is currently partly cloudy with a temperature of 16 degrees.
And that's something that I send myself every day, 6 o'clock. And I basically just a voice of, like a TTS voice of the current weather and some of the other details, like my YouTube statistics and that sort of stuff, which I like to listen every time, every morning. And that is being generated by this piece of code, which is getting executed 6 a.m. every morning. And again, it is just basically about 2 API calls. So it goes to the forecast.io and it goes to the YouTube channels API. And once the details are returned, then it just puts some text together, like, what is the wind temperature? What is the current state of the weather? What is the maximum temperature expected for the day, and the rain and wind speed and wind direction and that sort of stuff. And it is being generated for the forecast, weather forecast, and also for the YouTube. It is joined together, in this case it's joined together as a string, so basically the two just get concatenated one after the other. And that's pretty much it. And here I have used this specific node, which is called the voice RSS TTS. Let me find that for you. So it's this one, Node-RED Country voice RSS TTS. And I'm using this particular node because it's fairly easy to use. You send in a text. I think there is, I can't remember them. Maybe there is a limitation how long text you can send in, but I'm sending quite a long one in, and it's not an issue. Again, you have to go online, create an account, get an API key, and I think there is a limit of 10 voices per day. But I'm usually doing one, so that's I'm well below the limit. And it's not as nice as the Google text-to-speech, but it's nice. So what this node does, it calls that API, it sends in the text, and then it receives the response, and it saves the response in an MP3 file, and that basically in the output you will get the file name. So all I'm doing is I'm putting in, okay, my chat ID, which I basically hard-coded in here. I'm saying that, okay, I want the voice, and then the content is the message.payload. So that message.payload is going to say, like, you know, /home/pi/ you know, something from MP3. I think it automatically generates a file name, or maybe you have to provide a file name. I can't remember. If you debug the message, then the message is going in and out, you will see. So we are putting the so we are putting this MP3 into the message. We are sending it back to Telegram, and just for good housekeeping, after 2 minutes I delete this file, so it's no longer on the Pi. So again, that's a fairly easy piece of code, how you know, instead of generating a simple text, you generate a voice. And the last piece is really about my Doorbell integration. So whenever I receive an RF link or doorbell trigger that, you know, somebody presses my doorbell, that I'm sending out 2 messages, and that's basically just simple messages which says that, you know, there is somebody at the front door. And the only reason I have 2, because I have hard-coded my chat ID and my Mrs.'s chat ID here, and not in here, but at the same time the RF link piece of code is also triggering the NVR flow to take an image of the IP camera, and once that is done, once the image is taken, that information comes through here, and that's the one which is sending out the images. So when the doorbell is pressed, I immediately get a text, and then after about 5 seconds, once the image is taken, I will receive the image as well. So I always get 2 messages, and of course everything goes back to the, you know, this what is it, the Telegram sender. And it doesn't really matter whether you have one Telegram sender or multiple, as long as they are connected to the same bot. You can have as many as you want, and it would function the same way as you if you would only have one and connected all your nodes into that one. So that will be my quick look of my Telegram integration with Node-RED. As usual, you will find all the links in the video description. So I will put the link to this blog post. I will also put the link to this whole flow, so you can download the flow and you can start modifying. I'm going to put the entire flow in it, and I will try to do my best in order to, you know, delete all the chat IDs and the API keys that are specific to myself. So in most cases you will see some, you know, placeholders or X's or something like that in those places. So you need to provide your own, create your own accounts. Otherwise it's not going to really do anything. I hope this video was enough to just show you the whole concept, how I designed this flow, and hopefully that's modular enough for you to, you know, to modify it easily. I mean, at least I tried this part to be really, really modular, so it is easy to, you know, copy these function nodes, link the new ones into this basically cascading flow, and then create new functions and add new functions to this flow. There is still, I would say, a lot to do on this one. In the future, I would like to change this language processing part with the Ecolet node, on which I've done a separate video a couple of months ago, and I don't really like this part as well. So I have these few examples, so this voice statistics and the doorbell one, where I have actually hard-coded all the chat IDs into these function nodes, which is all fine, because basically in my specific case there are only 2 users, so it's easy to remember their chat IDs. But in the future it would be nice to implement something a little bit more configurable, where you would have, I have some ideas where you have these services. So for example, this morning voice statistics would be a service, and the doorbell would be a service. And within Telegram or within the UI, you can subscribe to services. So then there would be a piece of code here which says, okay, which are the users who are interested in the doorbell, and then send the messages to them based on the user list, and not based on, you know, hard-coded chat ID values. I hope you find this video useful. Thanks for watching, and hopefully see you in the next video.